Hello and welcome to everybody in Applied Mechanics. Bisek presented Applied Mechanics lecture series. Myself Hitesh Kanani. I am a lecturer in Applied Mechanics, and today we are going to study regarding a simple lifting machine, that is a Unit 7 simple lifting machine, lecture 1. Let's start with the history of the simple lifting one. Before engines and motors were invented, people had to go things like lifting or pushing heavy loads by hand. Using an animal could help, but what they really need were some clever way to either make work easier or faster. Now, regarding simple machines, ancient people invented simple machines that would help them overcome resisting force and allow them to do the desired work against those forces. Let's start with the machine. A machine is a device which is capable of doing useful work. A machine receives energy in some form and uses it for doing a particular useful work. The machine may be of following two types. First, simple machines. Second, compound machines. Let's understand simple machine. A machine which has a 1 point for application of load and 1 point for application of effort is called simple machine. Its mechanism is simple. It is a device that helps make work easier to perform by accomplishing one or more of the following functions: transferring a force from one place to another, changing the direction of a force, increasing the magnitude of a force, or increasing the distance or speed of a force. Now, regarding the usage of simple machines. Simple machines help people lift or move heavy objects, split thick solids, and secure things together. Simple machines are of a basic 6 types. Let's see one by one. First is a lever. Second is a wheel and axle. Third is a pulley. Fourth is an inclined plane. Fifth is wedge. And sixth is screw. Let's see individually. First, lever. It is a long piece of a wood, metal, or etc. which test on the turning point, fulcrum, to lift or open something. So here we can see that fulcrum is there. Force is applied on this part downwards and weight is acting on this part. This is a graphical represent and which is actually represented below. So that is a lever. Examples of levers are bottle openers, scissors, hammers. Now let's move towards the pulleys. A pulley is a wheel and axle over which a rope or chain is pulled in order to lift or lower heavy objects. Here in a side we have shown two pulleys. First is a pulley and first is a directly load is shown there. So here we can see that with the use of a pulley we can require less force, whereas without the use of the pulley we have to lift it directly and it requires a higher force. Pulleys change the direction of motion or a force applied to the lift and object. So that is a function of pulleys. The amount of force required to move the object remains the same. It only transfers it in another direction. Now, inclined planes. An inclined plane is a surface set at an angle against the horizontal. Inclined planes split gravitational force into force parallel to the plane and force perpendicular to the plane. Force required to do work is less than when pushing on a flat surface. Now move towards the wedges. Wedges consist of a pair of inclined planes set against each other. Here in a figure we have shown that this is a wedge and hammer is impacted on it, and that object is moving downwards. That way it splits the object. Similarly, here another figure, load is lifted by effort, so that wedge is pushed horizontally inwards, that moves the load upwards. Wedges are used to separate or hold objects. Door stops, axes and teeth are example of commonly used wedges. Now wheel and axle. A wheel and axle is a simple machine made up of two circular objects of different sizes rotating on the same axis. The wheel has the larger diameter and turns about the smaller axle. A force applied to the wheel is multiplied when it is transferred to the axle, which travels a shorter distance than the wheel. Since the wheel is larger than the axle, it always moves through a greater distance than the axle. So here in figure it is shown, some wheels are shown, and there on a center part there is a axles there. Another view of the wheel and axle is shown below. It is graphically represented. Then screws. A screw is another type of an inclined plane. It is a helical inclined plane wrapped around a cylinder to form a spiral with a wedge at its tip. The main use of a screw is to hold objects together with its helical grooves. Below are the figures shown of screws. So we have seen a simple machines. Now compound machines. A machine which has a more than 1.4 application of load and effort is called a compound machine. Examples are lathe machine, printing machine, milling machine. Those are the example of compound machines. Now let's see lifting machines. The machine which are used to lift the load are known as the lifting machines. The force required to raise the heavy load is much smaller in lifting machines. Lifting machine may consist of a simple machines or compound machine. Now let's see various terms related to lifting machines. Here we have taken one pulley where load is shown with W and effort is shown with P. So what we need to do is here is a lift load with the help of effort. So load, it is a load to be lifted by lifting machine. So any load can be there which can be lifted. Now regarding the effort P, it is the amount of force required to lift a given load for a lifting machine. Next is a displacement, distance moved by load X. It is the amount of distance moved by load in a lifting machine. It is shown with the X. So here is a weight. Weight is whenever lifted it moves upwards. So distance travelled is also in upward direction. Distance moved by effort. Here it is shown with a Y. It is the amount of distance moved by the effort during lifting of load. So whenever we are lifting weight, so X is moving upward whereas effort is moving downward. Hence the distance Y is moving downward. It is shown with that. Now another term, that is mechanical advantage. It is defined as the ratio of the load to effort required. Mathematically we can say that mechanical advantage MA is equal to weight W divided by P. MA is a unitless quantity. Now next term is a velocity ratio. It is defined as the ratio of the distance moved by effort to distance moved by load. It is a ratio of the two distances, hence its unit is unitless quantity. VR is y by x, that is distance moved by effort to distance moved by weight. Now input work. Work is basically defined as a product of force and distance moved in direction of force. So it is a product of effort P and distance moved by effort, that is y. Mathematically we can write as W input, that is a input work, is equal to effort P into distance traveled by effort, that is y. Input work is generally expressed as a Newton into meter or a joule. Another term is a output work, that is denoted by W output. It is a product of load W and distance moved by the load, that is x. Mathematically we can say that W output is equal to weight W into displacement or a distance traveled by weight, that is x. Since it is a work, its unit is Newton into meter or joule. Next is the efficiency of machine. Efficiency of machine is defined as the ratio of output work to input work. Mathematically it is denoted by eta, which is equal to W output, that is output work, divided by W input, that is the input work. It is expressed normally in percentage, hence it is multiplied with 100. So efficiency eta is generally expressed as percentage. Efficiency of machine can also take another form. Now here eta is equal to output work divided by input work into 100. Now from the earlier definition of output work, we can put values of output work as a weight into distance moved by weight, that is W into x, and effort multiplied by distance moved by effort, that is P into y. Rearranging it results into W divided by P divided by, in parenthesis, y divided by x. W divided by P is nothing but it is a mechanical advantage, and y divided by x is nothing but a velocity ratio from the earlier definition. So from this we can say that it is also defined as a ratio of mechanical advantage to velocity ratio. Now let's move towards the ideal machine. What is ideal machine? Ideal machine is a machine which is having an efficiency of 100%. You can say mathematically eta is equal to 100%. Or from the earlier definition we can say eta is equal to mechanical advantage, that is MA, divided by velocity ratio, that is VR, that is equal to 1. Or by equating MA is equal to VR. In other way we can say that it is also defined as the machine having a mechanical advantage and velocity ratio same. So ideal machine is a machine in which mechanical advantage and velocity ratio are same. Now in terms of other equation we can also derive it. First put eta is equal to 100%. Now what is the efficiency? It is a output work divided by input work. Mathematically output work divided by input work, that is equal to 1. By equating we can say that output work is equal to input work. Hence we can say that ideal machine is also defined as a machine in which output work is equal to input work. Now ideal effort, that is denoted by P0. effort required in an ideal machine is called the ideal effort, P0. From the definition of ideal machine, mechanical advantage is equal to velocity ratio. Putting value of mechanical advantage as a weight divided by force or a load divided by effort and arranging it in form of effort, ideal effort is equal to load divided by velocity ratio. Now ideal load, that is W0. Load for ideal machine is called ideal load, that is W0. From the definition of ideal machine, we can write as mechanical advantage is equal to velocity ratio. Putting the value of mechanical advantage as load divided by effort is equal to velocity ratio. Rearranging load, we can say that W0 is equal to effort into velocity ratio. So we can say that ideal load W0 is equal to load effort multiplied by velocity ratio. Now regarding the friction and its effect in a lifting machine. Actually in a real world, no machine is possible without friction. So no machine in a real world is an ideal machine. Hence every machine is having some frictional effect. Let's understand effect of friction in lifting machine. First, let's understand effort lost in friction, that is a frictional effort. It is defined as the effort required to overcome the friction in machine is called frictional effort. Now next terminology, we mathematically write equation of frictional effort. So for that, total effort supplied to machine is divided into working against friction and doing a work against load. So mathematically we can write that total effort provided, that is P, which is subdivided into two parts, frictional effort, that is PF, and ideal effort, that is P0. Mathematically rearranging frictional effort, we can rewrite as a frictional effort is equal to effort minus ideal effort. By putting value of the ideal effort, we can mathematically write as a frictional effort is equal to effort minus load divided by velocity ratio. So this is how we can derive a frictional effort. Then frictional load. Portion of a load acting as a frictional part of a load is called a frictional load. Now we have to derive mathematically equation of frictional load, that is WF. So total load in a machine is subdivided into two parts, that is frictional load and working load. Hence we can write as ideal load, that is equal to frictional load plus actual load. By rearranging, we can write that frictional load is equal to ideal load minus actual load. Again, putting the value of ideal load, we can formulate the equation of frictional load, that is WF is equal to effort into velocity ratio minus actual load. Now let's take an example on simple lifting machine. In a certain weight lifting machine, a weight of 1 kilonewton is lifted by an effort of 25 Newton. While the weight moves up by 100 millimeter, the point of application of effort moves by 8 meter. So that is a data provided in an example. So from that we have to find out first mechanical advantage, second velocity ratio, third efficiency of machine. Let's see solution of that. In data, weight is provided as a 1 kilonewton, that is converted in a newton as a 1000 newton. Now effort P, which is provided in a data, that is 25 newton. Distance moved by weight, that is denoted by x, which is provided in a data, that is 100 millimeter, which is converted in a meter, that is 0.1 meter. Distance moved by effort, that is denoted by y, that is equal to 8 meter. Now we know that mechanical advantage MA can be written as a ratio of the load to effort. By putting the value of load and effort, it is equal to 1000 divided by 25. By calculating, we can get mechanical advantage of 40. So that is our first answer. Mechanical advantage we get is a 40. Now move towards the second thing, that is velocity ratio. We also know that velocity ratio is defined as a VR is equal to y by x. Y is a distance moved by effort and x is a distance moved by load. In data, it is provided that distance moved by the effort is 8 meter, whereas the distance moved by the load is 0.1 meter. Calculating it, we can get a value of 80. So here we can get a second answer, that is the velocity ratio is 80. Now efficiency. From the definition of efficiency, we can put values of efficiency is equal to mechanical advantage divided by velocity ratio into 100. It is expressed in terms of percentage. From the earlier calculation, we have a mechanical advantage as 40, whereas velocity ratio is 80. Calculating, we can get that efficiency of machine is 50%. So by this way we can solve the example. Now move towards the second example. Data is provided in this example is, in a lifting machine, an effort of 40 kg just lift a load of 800 kilograms. What is the mechanical advantage? So we have to find out first mechanical advantage. If efficiency of machine is 40% at the load, then calculate velocity ratio of machine. So in this example we have to find out first is a mechanical advantage, then velocity ratio. Two things are required to be determined. So let's see the solution. In given data, we have an effort which is 40 kg. Another data which is given is load, that is 800 kilograms. We know from the mechanical advantage equation, MA is equal to load divided by effort. Putting values of the weight or a load and effort, that is 800 divided by 40, we can get mechanical advantage of 20. So here we have a solution of half part, that is mechanical advantage MA is equal to 20. Now regarding the velocity ratio, we have to find out. Here in a data it is provided that the efficiency is given as 40%. So we have to utilize the equation of efficiency. We know that the efficiency is defined as eta is equal to mechanical advantage divided by velocity ratio into 100. It is expressed in terms of percentage. Putting the values of mechanical advantage and efficiency in the equation, we have a efficiency is a 40. So putting value of it, mechanical advantage of 20 and velocity ratio is to be determined. Putting values and rearranging it, velocity ratio is a 2000 divided by 40, that is turn up to 50. So we have a answer of velocity ratio, that is 50. Now let's move towards the third example. A load of 120 Newton is raised by means of certain weight lifting machine through a distance of 200 millimeter. If the effort applied is 20 Newton and has moved through distance of 1.5 meter, find the efficiency of the machine. Now let's see solution of that example. First, data which is given, that is weight, that is load, W is equal to 120 Newton. Effort which is given in a data, that is 20 Newton. Distance moved by weight which is given is a x is equal to 20 millimeter. Distance moved by effort, that is y, that is given in terms of meter, 1.5 meter, which we can convert in a millimeter, that is 1500 millimeter. Now we know that mechanical advantage MA is equal to load by effort. Putting values of the load and effort in this equation, we have a load of 120 Newton and effort of 20. So mechanical advantage which comes out as 6. So we have an answer of mechanical advantage, MA is equal to 6. Now regarding velocity ratio, we know that velocity ratio VR is defined as the ratio of distance moved by effort to the distance moved by load. So it is a y by x. Putting the value of y and x in equation, we have a value of velocity ratio comes out as a 7.5. We also know that efficiency eta is equal to mechanical advantage divided by velocity ratio into 100 as expressed in terms of percentage. Putting values of mechanical advantage and velocity ratio in the equation of efficiency, we have a mechanical advantage of 6 and velocity ratio of 7.5. So answer comes out as efficiency eta is equal to 80%. Hence, this is the solution of example number 3. Now move towards the example number 4. Data provided in example number 4 is, in a weightlifting machine, an effort of 50 Newton is required to lift a load W. The distances moved by the load and effort are 20 mm and 500 mm respectively. Determine the magnitude of the load W if efficiency of the machine is 80%. So here in this example, W is an unknown and we have to find out it. Let's see the solution of this example. In data, efficiency is provided to us as well as the distance moved by the weight x is also provided, that is 20 mm. Distance moved by the effort, that is y, is equal to 500 mm. We know from the velocity ratio equation that velocity ratio is equal to VR is equal to y by x. Putting the value of effort and weight in the equation, so we have a velocity ratio of 25. Now we have a efficiency equation, eta is equal to mechanical advantage divided by velocity ratio into 100 in terms of percentage. Putting the values of mechanical advantage and efficiency in that equation, so efficiency given in data is 80, whereas velocity ratio which is calculated earlier is 25. Calculating and simplifying it, MA results as a 80 divided by 4, that is 20. So by calculating this, we can get a mechanical advantage of 20. Now we know that mechanical advantage is a ratio of load upon effort. So here we have calculated mechanical advantage, that is 20, and effort is given in a data, that is 50. So putting the values of mechanical advantage and effort in this and simplifying the equation, we have a load W, that is equal to 20 multiplied by 50, that is 1000 Newton, which results into 1 kilonewton. Now move towards the example number 5. In a certain weight lifting machine, an effort of 25 Newton can lift a load of 315 Newton. If the velocity ratio of the machine is 14, find the effort lost in friction and frictional load. So this is one example given to us. Let's see its solution. In present data, effort P is given as a 25 Newton. Load W, that is provided as a 315 Newton. Velocity ratio, which is provided in a data, that is VR, is equal to 14. We also know that efficiency, we also know that from the frictional effort equation, PF is equal to P minus load divided by velocity ratio. So here we have a value, putting a values of the effort, that is 25, putting value of the load, that is 315, and putting values of the velocity ratio, that is 14. So it turns out to as equals to 25 minus 22.5. It ultimately results into 2.5 Newton. Now we have already calculated frictional effort. Now calculating a frictional load. So equation of frictional load is a WF is equal to load divided by velocity ratio minus effort. Load, which is 25, velocity ratio, which is also given as a 14, and P, that is 315. Putting values of that, multiplying a 25 with the 14, we get a 350 minus 315 Newton. That result out as 35 Newton. Now in a whole lecture, what we have seen is today is first is a simple machine. What is in a simple machine? That history, what is simple machine, types of simple machine, that we have seen. Then other various types of simple machine like a lever, wedge, inclined plane, wheel and axle, screw, simple, those are already demonstrated as well as shown here. Then simple machine and compound machine, what is the difference between that? That we have seen, defining simple machine and compound machine. Then regarding the lifting machine and various terminology of lifting machine like mechanical advantage, velocity ratio, efficiency, output work, input work, frictional load, frictional effort, those we have seen. And also we have seen various examples based on the above topic. Thank you.